Hi, welcome. So I'm doing a 101 right now. We're going to be talking about midpoint in parallelograms, and this has come up a couple of times, and so I just want to take a moment to review what you can use the midpoint formula for when you're dealing with parallelograms. So the first thing that we need to do is remind ourselves what our midpoint formula is. So let's just start off with that. Here's the midpoint formula, and the midpoint formula says that the x-coordinate of the midpoint, which I'm going to use big M and then subscript x to represent, and the y-coordinate of the midpoint, again using big M for midpoint, the subscript y for y-coordinate, is given by this formula. Take the two x-coordinates of the 2 points you want to find the midpoint of, add them together, divide by 2. Do the same thing to the y-coordinates, and you have your midpoint formula. All right, so using our midpoint formula, we are going to be figuring out if things are parallelograms or not. So the reason we're doing this is because back in your properties of parallelograms, we had one property of a parallelogram that said that diagonals bisect each other. And because diagonals bisect each other, this means that they have the same midpoint. So this is a property of parallelograms. I don't have enough room to write it. All right, so I'm going to dig into my textbook really quickly, and I'm going to grab some numbers here of, whoa, overboard. Thank you very much to the helper who is off screen picking that up for me. I'm just going to continue, and if you don't get that all picked up, don't worry about it. I will pick it up later. Just throw it on that desk there. Thank you. All right, so I'm going to find the coordinates of some sort of parallelogram. Here we go. Let's say I have these coordinates. A is sitting on -6, -5. B is sitting at -1, -4. Thank you, don't even worry about how it's sorted. C is sitting at 0, -1. D is sitting at -5, -2. All right, so here's our coordinates, and we don't know if this is a parallelogram or not, but we know that the diagonals bisect each other. So I'm going to give this a real quick sketch so that we can see más o menos sort of where it is. Looks like we've got a lot of stuff in the negatives, so I'm going to go ahead and kind of focus in on the negative axes, and I need to go, looks like the biggest one is 6. So 1, 2, 3, 4, 5, 6, really kind of small. I guess let's do 1, 2, 3, 4, 5, 6. Those look a little better. 1, 2, 3, 4, 5, and 6. Okay, so I've made myself a real quick grid. I'm going to graph these. These are at 6, 5, both negative. So there's A. B is at -1, -4. So there's B. C is at 0, -1. And D is at -5 and -2. Okay, and then I'm going to go ahead and use my straight edge so I can get some good clean lines. All right, now because I didn't draw this on graph paper, it's probably not to scale. And looking at it, it kind of doesn't really look like a parallelogram. But remember, this is a quick sketch and our eyes could deceive us. We have to confirm this. And the way we're going to confirm this is by using this idea that diagonals bisect each other. That means that if I were to draw the diagonals that goes from corner to opposite corner, whatever point this is, they're going to share it. And that is going to be the midpoint of each of these segments. So I'm going to find the midpoint of AC, and then I'm going to find the midpoint of DB, and I'm going to compare them. And if they are the same value, then they bisect each other, they share a midpoint, And so this thing is a parallelogram by definition. My midpoint formula says take the x values of the 2 points that I'm interested in. So in this case, it's going to be A and C. So I'm going to take the x coordinates of those and add them together, divide by 2. I'm going to take the y coordinates of those and add those together, divide by 2. And when I'm done, I end up with something that looks like this. I think I missed a sign. Yeah, I missed a sign here on the point of A when I copied it down. So there we go. And when I reduce those fractions, I get a coordinate of -3, comma, -3. Just going to zoom in a little bit. All right, I'm going to do the same process for D and for B, and I'm going to see what I end up with. So there's the x coordinates for B and for D, and adding them, dividing by 2. The y coordinate of B added to the y coordinate of D, divide by 2. So this is -6 and 2, 2. And once again, it looks like when I'm done with my reductions, I end up with the coordinate -3, -3. Since they have the same midpoint, they are indeed bisecting each other, and so I can say that yes, figure A, B, C, D is a parallelogram. And I have to give a justification, so I'm going to write the word because the diagonals bisect each other. And I know that because they share a common midpoint, as was calculated using midpoint formula in the figure above. Okay, I want to take a moment to talk about what we can do with the midpoint formula beyond this. Let's say I was given the midpoint, as we saw in our quiz. You were given a midpoint of a parallelogram, and you were asked to find the coordinates of one of the sides. So you were given, say, parallelogram, let's write it properly, parallelogram ABCD, and you know the coordinates of one of them. So I'm just going to pick a letter at random, and I'm going to grab just kind of one of these random points that I have in my textbook from a different problem. This is supposed to be a 2, I'm sorry. So parallelogram ABCD with point A sitting at 2, 2. What we want to do is we want to find the coordinates of C if the diagonals AC and BD intersect at, I'm going to make up a number here, -4, -6. Couple things that you need to know before you deal with this problem. First off is this idea that the diagonals bisect each other, which means that if they're intersecting at -4, -6, this -4, -6 is the midpoint of line segments AC and BD. So the first thing we need to know is that -4, -6 is the midpoint of line segment AC, and it's also the line segment, or also the midpoint of line segment BD. With that, I can start to calculate what I'm missing. I'm given A, which means I don't really care anything about BD. I'm going to look at line segment AC. Because our formula states that my midpoint is given by adding the x coordinates together and dividing by 2, and doing the same to the y coordinates, I can substitute what I know. I know that A is 2, 2, and so this is my x1, y1. Or your x2, y2, it doesn't matter, you pick. I'm also told that the midpoint is -4, -6. And so this is your midpoint x-coordinate and your midpoint y-coordinate. And now I can substitute and solve. I'm going to show the solving of just the x-coordinates and allow you to work through the solving of the y-coordinate on your own. Alright, so I'm going to substitute just the x's. My mx, my midpoint x-coordinate, is -4. That needs to equal what we get here on the x-coordinate, which is going to be x1 given by 2 plus x2. I don't have to write the subscript anymore because there's only one x in there. So I'm going to go ahead and leave the subscript off. I no longer need to differentiate which is x with the first point, which is x of the second point. I don't know about you, but I see an equation with a fraction in it, and it makes me very unhappy. I don't like to deal with it, so I'm going to get rid of the fraction. I'm going to do that by multiplying by its denominator. And I'm multiplying because a fraction bar means division. And so to undo division, I'm going to use multiplication. So this is me writing that I need to multiply both sides by the same number, which in this case is 2, the denominator of this fraction. Now I'm going to do my multiplications. 2 times -4 is -8. And then these two are going to actually end up canceling each other out. That was my whole goal because I want them to go away. And I'm left with 2 plus x. From here, I need to get x all by itself. It is all on one side of the equation. I don't see any other x's anywhere else. And so I can start to remove this 2 because it's in the way. What I do to one side, I have to do to the other. -8 minus 2 is a -10. And so the x-coordinate is -10. Pause the video now, work through the midpoint of y, and when you unpause, I'll walk it through for you very quickly. Take a moment to pause the video now. Alright, welcome back. We're going to go ahead and solve the midpoint of y. Here we go. Midpoint of y is given as -6. And here is the formula for midpoint, which says y1, which we have as 2, plus y2. Again, I am not going to put the subscript after that y because I only have 1 in my equation now. I need to multiply both sides by 2 in order to get rid of that fraction. So 2 times -6 is -12. And when I multiply this right-hand side by 2, the fraction goes away. I want y by itself. I'm going to do that by subtracting 2 from both sides. -12 minus 2 is 14. And the 2's on the right-hand side are going to cancel. And so the coordinate for C, which is the other side of that line that I was given one end and the midpoint of, is going to be at the coordinate -10, -14. All right, I hope that helps you decide how you can use the midpoint formula in order to confirm if a quadrilateral that you're given the vertices of is a parallelogram or not, as well as how you would use the midpoint formula in order to find one endpoint when given an endpoint and the midpoint. Thanks for watching. We'll see you on the next video.